Welcome, students. Today we'll look at basic tools of economic analysis, part 2. Note that we did basic tools of economic analysis, the first part, and this is the continuation. This picks up from where basic tools of economic analysis, the first part, ended. So we'll be looking at further statistical measures of further measures of statistics, not measures of central tendencies. So we'll begin with simple measures of dispersion. Simple measure of dispersion. Note that these are measures of the degree of spread around the mean. They measure the degree of spread around the mean. Note that in the part 1 we dealt with measures of central tendency, which were attempting to locate the mean or the center of a distribution. But here is further, we look at the measures of the degree of spread around that center, around that mean. So these measures include the range, the variance, the standard deviation. Okay. Start with the range, denoted as R. The range is the difference between the extreme items of a distribution. Note difference and extreme items. You take the extreme items and you find the difference. That is, you subtract the one at the extreme right from the one at the extreme left. No, you subtract the one at the extreme left from the one at the extreme right. Okay. An example. Following the distribution 13, 12, 5, 3, 3. Okay. I've colored the numbers at the extreme ends in blue. So 13 and 3 are at the extreme ends. You subtract, you find the difference, that's the range. So 13, the range is 13 minus 3. 13 minus 3, the extreme ends, this is equal to 10. So the range of this distribution is 10. The range is a measure of dispersion. Okay. Number 2, the variance. Variance is denoted as S squared. The variance is the square of the standard deviation. Variance is S squared. Standard deviation is S. So variance is the square of the standard deviation. It is denoted by S squared equals to sum of x minus x bar all squared over n. That's sum of each element, that's x minus its mean x bar over all squared, over the total numbers in a set. Don't get afraid or scared that you don't know what standard deviation is. I'm using it to define variance because the next point is standard deviation. And from standard deviation, you look at it and you say, if I square this, I get variance. Standard deviation gives a measure of the deviations of the readings from the mean. It is a concept which gives a measure of how readings disperse around the mean, move away from the mean, deviate from the mean, and the square of this is the variance. So the square root of the variance will give you, square root of S squared is S, so the square root of the variance will give you standard deviation, will give you S. That's how you get standard deviation. If you still haven't understood, let's look at that. Let's explain further the formula. S equals to the square root of sum of x minus x bar squared all squared on n. If you still haven't understood, we'll look at an example. For n equals to 14 and mean equals to 2, x, values of x, n is the total number of elements in the expression. Mean is 2, is denoted as x bar. The values of the set x 1, 2, 3, 4, 5 the values x minus x bar, that's each value minus its mean. Each value minus its mean. So for each x, you subtract it from the mean, which is 2. So 1 minus 2 gives you negative 1. 2 minus 2 gives you 0. 3 minus 2, 1. 4 minus 2, 2. 5 minus 2, 3. You understand now? Okay. Then, according to the formula, we have to square this x minus x bar. So, for each x minus x bar, we square. So, negative 1 squared will give x minus x bar squared. Negative 1 squared will give 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. And 3 squared is like 3 times 3 is 9. So, with all this gotten, we can get s. You can get s squared, which is the variance, sum of x minus x bar squared, which is 15, on n, which is 14. So 15 on 14 will get 1.07. To get now the standard deviation, which is the square root of the variance, it will be square root of variance, which is square root of 1.07. It gives us 1.03. So this value measures the degree of the deviation from the mean to the degree of deviation of these other values from the mean is 1.03. Okay, let's move now on to representation of data. Can be represented with graphs, histogram, bar chart, and pie chart. Data can be represented. You get data and you statistical data, analyze and interpret, and representing in such a way that people understand, can be on graphs, histograms, bar chart, and pie chart. We'll get to explain this. Okay, let's begin with graphs. This is a line that shows the relationship between two or more variables. A graph is basically is basically a line. We look at the straight line graph here. A graph is basically a line drawn on two axes, x and y axis, showing the relationship between what the x-axis represents and that y-axis represents. So let's look at an example to get this further. Assuming the price and quantity of good x. The price of x is 300, 400, 500. The price ranges from 300 to 500. It changes from 300 to 400 to 500. The quantity supplied in liters changes from 0 to 100 to 200. You see that as the price increases, the quantity supplied also increases, because producers will be producing more because they will have more profit from producing the same amount that they produced before, or supplying the same amount of that they supplied before. So I'll tell you that the graph now is a line drawn on two axes. So the first axis will present price, which is the y-axis, and this price, and this is CFA francs. Y-axis moving is a vertical axis, and it moves 300, it moves 200, 400, 600. The horizontal axis measures quantity. This is the x-axis, measures quantity, and from 0 to 200. Okay, so we're plotting 300 price against 100, against 0, 300 against 0, 400 against 100, and 500 price against 200 quantity supplied. This will give us this shape, a straight line supply curve. This is the concept of representing data in the form of graphs. We have represented a relationship between price and quantity supplied of group X. That's the data gotten from the price, changes in price, and the changes in quantity supplied. We have represented it on a graph, a straight line graph. You see now, this is the shape. A positively sloping curve, positive sloping supply curve. That's increases with increase in price. It has a positive relationship, a direct relationship. One is the cost in the increase of one is caused by the increase of another. Moving on, histograms. This is another form of representing data, a chart called a histogram. A histogram is also a form of representing data. You present on two axes again, y and x axis. And let's show you how it comes up. The y-axis frequency and the x-axis will put something else. The y-axis runs from 1 to 5, and the x-axis, let's represent marks in this case. So the marks are from 0 to 70. Each mark represents its frequency. So 20 appears. So the frequency of marks between 0 to 20 is 1, as shown here. The frequency, the amount of times marks occur between 0 to 20 is 1. From 20 to 30 is 2. The amount of people with marks from 20 to 30 is 2 people. The amount of people with marks from 30 to 40 is 4. 4 people, 4 appearances. The amount of people from 40 to 50 remains 4, is still 4. The amount of people from 50 to 60 is 3, and the amount 60 to 70 is 2. Is 1.7, close to 2. Okay, you see, this is a representation of a histogram. Note that the bars are joined. There is no space between the bars. We'll explain this further. So we have looked at a straight line graph and we have looked at a histogram. What next do we use to represent data? Oh yes. So we'll look at the third, the bar chart. A bar chart is in the form, it's like a histogram. Same here is the y-axis. We put here, for example, number of cars from 5, 10, 15 up to 20 cars, and the y-axis years. Year will represent years. The bar chart it consists of bars joined equally, joined of equal width, but which length is proportional to the quantity represented in the data. The example here would deal with number of cars and the years. So 2000, 2002, 2004, 2008, how many cars were produced in these years? Note that this is hypothetical, it's not realistic, so the numbers may seem exaggeratedly small, but it's hypothetical. So in the year 2000, we'll see 5 cars. The year 2002, 10. The year 2004, we'll see 15. And the year 2008, you see 8 cars. So this, you see that there may be spaces in the bar chart, but a bar chart could also be drawn without spaces between the bars. These are just forms of drawing a bar chart. But I put a bar chart in this form so that we can easily differentiate between the histogram, between the bar chart and the histogram. Okay. Now that we have seen the histogram and the bar chart, they look alike. So we want to compare the two, the differences between a bar chart and a histogram. We have seen the similarities. They both have a y and an x-axis representing different things, and the relationship between those things in the form of bars. So let's look at the differences. What makes one a bar chart? What makes one a pie chart? Okay. The first, a bar chart has spaces between them, whereas a histogram has no spaces. When I say a bar chart has spaces, it mustn't have spaces, but a bar chart might be drawn with spaces between them. And it's still correct, it's still called a bar chart. But a histogram, when you just put spaces, it is not more a histogram. A histogram is never drawn with spaces between them, because the width of a histogram the size of the histogram may represent the area of the total area. The second factor, a bar chart can be drawn vertically or horizontally, but a histogram can only be drawn vertically, depending on your convenience, depending on how your pages or how the space you have. A bar chart can be drawn either way, vertically or horizontally. That's what was at the y-axis. You may bend the bar chart in a different dimension, but histogram is upright, always vertical, as how I drew the histogram. It can never be drawn in another dimension. So, assuming that you know about a bar chart and a histogram, and you know the differences between a bar chart and a histogram, let's move to a pie chart. A pie chart. You see, I'm looking at the angle, portion, total portion times 360 degrees. Don't let this scare you. A pie chart, with a pie chart, it's a circular diagram, and it's a way of representing data in terms of angles. So you see this angle, portion over total portion by 360. This is the angle of each portion of the set. So you are representing in a circular diagram, and each value is presented by an angle. So an angle is given. To look for the angle for each portion, you take the portion over the total portions times 360. If you don't understand this, we'll look at an example. A student with 1,000 francs intends to spend it on an exercise book which costs 250 francs, food which costs 500 francs, a pen, this pen costs 150 francs, a ruler which costs 100 francs. The student intends to spend the money on these things to distribute 1,000 among these things. So we want to see it in a form of a pie chart, how we represent it on a pie chart, a form of diagrammatic representation of data presented on a pie chart. You see, the first and most important thing here is finding the angle to give to each portion. As we saw, angle is portion of over total portion times 360 degrees. So, in order to represent this on a pie chart, we will need to find the angles for the various goods. So that's the first and most important thing. Exercise books. That is the first portion for exercise book, and it is 250 times 1,000. 250 over 1,000, times 360 degrees on 1. You see, the portion of the money which exercise book takes is 250 francs out of 1,000. 1,000 is the total portion, total amount, times 360 degrees. 360, a circle is 360 degrees over 1. So this is following that formula. This will give us 90 degrees dedicated to exercise books. 90 degrees. Next, food. Food, how much does food take? 500 over 1,000 times 360 degrees. That's 500 francs dedicated to food over the total amount in hand, 1,000 times the total angle of a circle, 360 over 1. This will give 180 degrees dedicated to food. So on that circle, 180. The angle 180 directed to food, 90 to exercise books so far. Next is pens. A pen, 150 for the pen over 1,000 times 360 degrees over 1. This will leave us with 54 degrees dedicated to pen. And the ruler, last but not least, the ruler, 100 over 1,000 times 360 over 1. We dedicate 36 degrees to the ruler. Now that we have seen all these degrees on our circle, we'll have to fit this within, we'll fit all these angles within 360 and name them depending on each portion. So this is the circle. Food, 180 degrees as we dedicated before. dedicated 180 for food, 90 degrees for exercise book, for the exercise book, 36 degrees for the ruler, and 54 degrees for the pen. So you see that this is what we did before. We were looking for these angles, and now that we've gotten angles, you see it's easy to put it on a pie chart. This is called a pie chart, what you are seeing in front of you. Okay, I hope you understood methods, ways of representing data on diagrams, the graphs, straight line graphs, histogram, bar chart, and pie chart. I hope you understood all the concepts. I hope you understood the variance. I hope you understood measures of dispersion, like the variance, the standard deviation, and the range. If you didn't understand, or if you want to read more on this, you can follow the following references. Go further and read. This is important. This book, The Beginner's Companion by Nwanji Victor and Tumlami Musa. Economics Made Easy by Whitehead. Elementary Economics by Harvey, and Intermediary Economics by Harvey. These books will give you more information on what I've just spoken about. Either of them. You can go to the internet and Google this, or go to wikipedia.org. So, all that, I'll have to tell you goodbye. We'll end here for today. Goodbye. And remember, hard work, thumbs up. Hard work, thumbs up to hard work. And thumbs down to laziness. No laziness. Hard work, no laziness.